Welcome, folks. It's the top of the hour. So let's go ahead and get started. My name is Kevin Petrie. I'm the VP of Research here at Eckerson Group. Really pleased to have the opportunity to talk about a topic that's near and dear to our heart here at Eckerson Group. I apologize, I seem to have an automatic feed on these slides. And what we're here to talk about today is the next wave of evolution, innovation in generative AI. And so I think this is going to be a very interesting discussion. There are two specific use cases that I'll walk through about how enterprises are feeding domain-specific data to GenAI language models in order to not just boost productivity, but gain competitive advantage. It's really important. It's critical to the role of the data engineer. As a brief aside, we have a poll running on LinkedIn right now. A lot of folks voting, and initial results are 85% say we're going to increase the demand for data engineers in 2024 as opposed to decrease. And things like generative AI will only increase demand as opposed to reducing the role of data engineers. So why don't I pause for a minute? I'm going to ask Cyril to introduce himself. I'll walk through some material to kick off the topic and then hand over to Cyril. Cyril, why don't you introduce yourself?
Sure, thanks, Kevin. Bonjour or bonsoir, wherever you are in the world. So I'm Cyril Sonfro. I'm Principal Product Manager at Matillion, and I'm in charge of the AI strategy and roadmap. So it's really a pleasure for me today to co-present that webinar and talk about how we can give a concrete answer to bring domain-specific data in the AI-fueled data pipeline.
Fantastic. Okay, so let's get started here. So I want to talk briefly about generative AI. Unless you've been living in a cave for the last year and a half, you certainly know the term and the technology. I do want to get a little bit beneath the covers to talk about what the fundamental principles are and concepts and the logical flow of this new type of artificial intelligence. Generative AI algorithms, it's a model that trains itself to generate digital content, such as text, most frequently, also images or audio files. Generative AI started gained first prominence in 2014 with the rise of generative adversarial networks, in which you have two different neural networks competing with one another. One creates fake depiction of, let's say, Joe Biden or Donald Trump or celebrities or other things, and the other neural network reviews that and says, yes, that's faked me out or not. And so you have this iterative competitive process that will create deepfake images and videos. Next, you had the rise of transformers, and this came largely with a groundbreaking paper from Google. It's about 5 years ago. And this is the notion of transformers. Transformers are a way to process and create sequences of data. That's the underpinning element of a language model, which is a transformer-based neural network that interprets and generates text. You'll also hear the term foundation model. That's sort of the broader term that can also generate images, audio, and so forth. So we're going to focus largely on text in this discussion, or at least my section. Language models answer prompts by predicting strings of words based on a corpus of existing content that they've been trained on. And so it's literally looking at a string of words, assessing the statistical interrelationships of those words based on words it's already studied, and then predicting what should come next in the string. It might get things wrong, but statistically, there's going to have a certain level of confidence that it's right. You can reduce the risks and the hallucinations, as we call it, by getting domain specific. We'll be talking about that. So advances in data collection, computing power, and algorithms are making GenAI feasible for a wide range of business applications. And that's why it's caught the attention of not just data scientists, but C-level executives. So let's look at an example here. If we have a document that's used for training purposes, the Gettysburg Address. 7 years ago, our fathers brought forth and so forth, Abraham Lincoln's very influential short document is an example. And so you can have a language model that's trained on this content with a corpus that would include that document. There are a few different key elements here, and I'll work up logically. The first is tokens. Tokens are essentially numerical versions of the words. Each word picture words from this document broken out in a CSV file. And then you can have chunks, and chunks might be the preamble, the body, the conclusion of this speech. It could apply to the Declaration of Independence. It could apply to other things as well. Then you're going to have parameters, and parameters are numbers that measure the relationships of chunks and tokens to one another. They're also going to quantify what the semantic meaning is of these chunks. Vectors are parameters that you put into a vector database. The attention network is going to study all these parameters to understand how one word, one token relates to everything else. And then you have on top of that a language model that's going to use the attention network to generate text when prompted. A lot of concepts at play here. Key point is it's turning numbers into words, studying how they relate to each other, what they mean, and then predicting words to respond to prompts. What can go wrong? All kinds of things. A lot of these have gotten a fair amount of focus, so I won't spend too much time on it, but you have hallucinations, which are inaccuracies due to inaccurate or insufficient inputs, lack of context. There's also a concern about explainability. If you don't know your sources, the lineage of your sources, or the algorithmic methods of creating these strings of words, you can have a lack of explainability, which can create auditor concerns and so forth. Privacy is obviously a concern. You want to make sure you're not exposing sensitive data to potential privacy breaches. Intellectual property is another concern. There are some landmark cases right now. For example, the New York Times has a court case, I believe, with OpenAI to figure out how they can make sure they're getting compensated for their content. And then, of course, there's fairness. You don't want to perpetuate bias that might be in the training data. So the key point of all these risks is that you can mitigate them a fair amount and get some competitive advantages by taking these language models and applying them to your own domain-specific data. And so that's where it gets interesting. Quickly, the adoption phases here that we've started with language model tools. ChatGPT took the world by storm, November 2022. Quickly, we had other high-profile releases. And so these generic tools can do some pretty interesting things without sufficient levels of accuracy in a lot of cases. But now you've got LM functions in adoption stage 2, in which knowledge workers are not just using ChatGPT or Google Bard or Bloom from Hugging Face. They're also using LM functions within tools. It might be GitHub Copilot, it might be Salesforce Einstein, and so forth. But the real innovative phase, in my view, and I think the reason we're here, is that you can have domain-specific GenAI, where companies are building language models into proprietary workflows. And they're doing this in two ways. They have LM embedded applications, and they have LM embedded data pipelines. As we get to this phase 3, we have a high reliance on domain-specific enterprise data, making sure it's governed. So domain-specific GenAI, in my view, is the next wave of innovation, and it's focused on LM embedded applications and LM embedded data pipelines. So both these use cases, LM embedded applications and LM embedded data pipelines, can support a range of use cases in customer service, document processing. Those two have probably gotten the most focus. There are also ways in which you can do specialized research. You can assist marketing or sales endeavors. Just to look at the customer service use case quickly, customers have been interacting with chatbots for some time. If you get a language model behind that, and you train that language model on a lot of historical conversations with customers, you train it on product documentation, you prompt it with product documentation, you can ideally enrich your interactions with customers, have faster resolution time for issues, and you can increase the cross-selling and the customer satisfaction levels. So that's the goal, and I think these use cases are pretty compelling. What I want to spend some time talking about are the two types of scenarios here. So scenario 1 is an LM embedded application. We could also call it a GenAI application. And this is going to include a language model. It could include, say, ChatGPT that was then fine-tuned on domain-specific data, training data, or potentially not. It's more of a generic model. It's going to be built into an application that also includes a chat interface with the user, maybe internal to the company, maybe external. And it's also going to include functionality that takes those words and puts them to work, takes the outputs of the language model. So the scenario here that's going to be very common is that you're going to have a data pipeline supporting that LM embedded application. And it's going to do it by taking the chunks and the tokens and the vectors that I described on the earlier slide, preparing that, taking a text file, going through this process of extracting and loading it into a landing zone, reformatting it, converting it to tokens and chunks, and then embedding the parameters that describe all this stuff, loading it essentially into a vector database. And that vector database is going to store this material, search and retrieve it in order to answer queries from the GenAI application. So the scenario here is a customer comes and says, I have a question about product functionality X and Y. And the GenAI application is going to ask the language model to answer that question. But within the prompt, it's going to insert the product document, the product guide, in order to give them essentially an open book test. So this is scenario one. You've got what's called retrieval-augmented generation to consume domain-specific enterprise data as part of the prompt. And this is how we're enabling LM-embedded applications. This is quite common. A lot of organizations are doing this. Various vendors, Matillion and others, are helping prepare this data in this flow. What's less common, what I think is particularly interesting and compelling, is figuring out, okay, let's look at scenario two. Scenario two is we've got an LM embedded data pipeline. And so here we've got a data source. Let's say it's a relational table. We're going to extract a certain table from it and then convert, let's say we extract tables from 5 different databases, convert all those records to a common format. And then you can actually prompt a language model to generate new entries to enrich that data. You could say, this is a customer list. I'd like you, ChatGPT, to describe that company to me, describe where it's located, describe some other attributes of it, and you'll have free text entries populated within an additional column. And that's what the language model is doing. And then you can prompt the language model to say, okay, now let's classify those. Let's classify the type of climate that these companies are in, temperate, tropical, mild, whatever it is. So now you can start to get back to something that's a little more structured. And that new table with the new column, the free text, but also the sort of classified derivations from the free text, can assist data analysts, data scientists, and so forth who want to visualize and report on and alert on opportunities related to those customers. Maybe they find unexpected correlations and cross-selling opportunities to recommend purchases to customers. And the embedded GenAI language model, by putting it within the database and by giving it to the data engineer who works in concert with the data analyst to enrich the information, they can really speed up the time it takes for data preparation. They can even reduce the number of data sources and pipelines they need to create because they're generating the stuff internally. Big caveat, of course, is that you need to carefully have human inspection of the quality of the outputs. And I think we all recognize that as a must-have requirement for almost any GenAI application right now, human oversight. But with that said, this is going to greatly reduce the time and enrich the possibilities for data engineering teams that are preparing data for all kinds of analytics. So again, we have LM embedded data pipelines that are using GenAI to enrich data for analytics by generating and refining new entries. So it's pretty cool stuff. So I'll wrap up here by saying that domain-specific GenAI offers a pretty compelling opportunity, not just to boost the productivity of knowledge workers or others, but also to gain competitive advantage because you're really digging into your own data, which reflects your own business and describes your own business. And that's where you can have a real proprietary advantage. To get started on this, it makes sense to, as with any technology endeavor, identify and prioritize use cases for domain-specific GenAI, and do that by working with the business and saying to the business users and the business leaders, where do you have pain right now? Where do we have a problem that we need to solve? Maybe it's that the process for the ways in which we process mortgage loan applications and generate standard contractual language for customer-specific scenarios is too slow. There are ways in which GenAI could intercede and assist the RPA or robotic process automation for that. That's one example. Obviously, customer service is where there's a fair amount of pain, and if handled right, you can use customer service to improve outcomes in terms of customer interactions. Once you prioritize those use case bases on relative pain and upside as counterbalanced by risk, you can choose the approach. You also want to figure out, okay, what's the technical maturity of my organization? Are my data engineers ready to start using ChatGPT to enrich data? Are data analysts ready for that? And so forth. And you want to make sure that what's the risk of hallucinations? What's the ability to reduce inaccuracies in data? And then finally, you want to make sure that you're maintaining human oversight at each step in the way and adapting your data governance programs to mitigate risk. I think the good news is that while very few enterprises would say we've cracked the nut on data governance, we figured out and solved the problem, most organizations of size do have a data governance program and do have established policies and roles and so forth related to data governance. And those can be extended. All the right elements are there. It's just they need to be extended and adapted to address text data, other types of less structured data objects, as opposed to the traditional tables. And it needs to be, as well, when looking at people and process, you're starting to have a governance program that addresses new roles, ML engineers, data scientists, and addresses new type of regulatory risks, regulatory requirements. For example, those likely to be formalized in the European Union. So domain-specific GenAI does offer a compelling opportunity to gain competitive advantage, one, through LM embedded applications, and two, through LM embedded data pipelines. And now I'm going to hand over to Cyril, who's going to dig into this, in particular focus on LM embedded data pipelines. So looking forward to it. Cyril, why don't I let you share your screen and we can get started here.
Thanks a lot, Kevin. So let's talk about the LLM pipelines, the LLM data pipelines, and let me introduce Matillion Data Productivity Cloud. So what we bring here is a data productivity platform. The goal is to help customers load their data into their warehouse of choice. And the benefit here is we bring a big set of connectors so that you can tap into a wide set of sources. And I think that's a fundamental element when it comes to LLM pipelines, because you need data in order to get insights out of an LLM. So AI is the fuel here, and we're enabling that data into the warehouse. We're also bringing many capabilities when it comes to graphically design data pipelines. One of the specifics of Matillion is that those pipelines are going to run natively on the warehouse. We ease the transformation of the data and the orchestration of the data. And the last bit is about making that data ready for the business. So we enable a delivery of data, whatever the use case, that can be for analytic use case, data science, or operational analytics. So you get the point. What we bring is a low-code approach to creating graphical pipelines. To resonate with what has been presented by Kevin, one particularity is that we're also enabling AI as part of the pipelines. So we bring graphical components that can help operationalize the use of large language models and industrialize the use of AI so that you can run that kind of pipeline at scale. So back to some of the statements that have been made by Kevin in the previous slides. We're seeing also AI as a way to bring competitive advantage. If you think about it, some of the use cases that are enabled by AI were physically impossible 9 to 12 months ago. And we think that's an opportunity for our customers, and that's what we want to enable as part of Data Productivity Cloud. So talking about the use cases where AI can bring value, the interesting part is that not a single department is outside of the story. We're talking about data enrichment, knowledge management, customer satisfaction, and sentiment and customer insight, sales and marketing, employee training and support, innovation and research. There's value that can be unlocked in each and every functional area of an enterprise. And our goal is to provide the tooling that's going to be relevant, whatever the functional domain, so that at the end of the day, our customers can create data pipelines that will bring that competitive advantage. So going a little bit deeper into the very AI pipeline, it really resonates when it comes to tapping into the sources of data that are going to be relevant for AI. That's something where we shine. We have that palette of more than 100 connectors. So you can pick the most relevant source to address your use case. Something that Kevin just said, which I think is really relevant, is the governance and the data quality piece when it comes to AI. You need to prepare that data for the use cases that you want to implement. And again, that's something that we ease throughout graphical components in a low-code approach, so that any data engineer is going to be able to make the data ready for AI and maybe tweak it and tune it so that it's fit for the use case that needs to be implemented. Also, we talked about the vector databases, and we're seeing vector databases as used more and more to extend the knowledge of large language models. Again, you need tooling when it comes to loading the vector databases at scale and bring the data coming from all the sources of your information system. So embedding the vectors and then making sure that those vectors are fit for the use case and can be used with the large language model, ensure that they duly extend the knowledge of the large language model, is something that we're easing with Data Productivity Cloud. From an outcome perspective, we want to ensure that the data pipelines can help putting together the AI apps that Kevin has been presenting, the AI apps being the second fold of Kevin's presentation. Something that is important is also the breadth of data that you're going to use in AI. So far, we've been mostly relying on text data. And if you take data pipelines, they've been mostly relevant with text data. But we think that AI is going to be a great opportunity to start tapping into unstructured data. So we think that AI is going to be a great way to put more data at work and unlock even more use cases by leveraging that unstructured data. So if you take data as a pyramid, so far the realm of structured data and semi-structured data has been pretty well addressed in the world of data pipelines. But when it comes to unstructured data, there have been few challenges because that data is harder to access. Here we're talking about the images of the world, the transcripts, the documentations that might not be very well structured. One of our goals and targets is to ensure that you can load any data into the warehouse and you can put it at work so that you make it business ready. And that's where AI is going to be an enabler. We think that AI is going to be one way to leverage those sources of unstructured data that were so far untapped opportunities. Also, we think that more data is going to help bring even more context for large language models, and at the end of the day, unlock even more accuracy. So the first approach that customers often have with AI and large language models is to do something that is called prompt engineering in a zero-shot manner. We take the knowledge of the large language model as is. So you take, for instance, ChatGPT with its built-in knowledge. That's already very convenient to address some of the use cases that we've seen previously, because the level of reasoning that's available in the latest large language models enables to address already pretty deep business questions. But sometimes you need also to take into account the very data coming from your internal sources. There are questions that ChatGPT cannot answer because it simply does not know your context, your knowledge, and you need to feed the large language model with your very data. So that's what we call retrieval-augmented generation. And that's something that we're enabling as well with Matillion Data Productivity Cloud, again, using graphical components and a low-code approach. And moving on to even more accurate answers and even more task-specific uses of large language models. Something that can be enabled in the data pipeline is called the fine-tuning of a model. It's all about sending labeled data to a large language model so that you can adapt its parameters and so that you can fine-tune it so that it's excelling at given tasks and at doing specific answers on given data. So from a scope perspective, what we want to enable using the low-code graphical components is prompt engineering, retrieval-augmented generation, and fine-tuning of models. So the RAG is a new template that we're seeing and that we're enabling with those graphical components. Back to some of the challenges that Kevin talked about. One caveat of loading vector databases is to ensure that the vector database is loaded with accurate data with a level of quality that will ensure that the answers you're going to get out of AI are relevant and duly address the use case that you want to implement. So what we enable with Matillion is the ability to also prepare the data. We see data preparation as being an essential step when it comes to feeding the vector stores so that the large language models are going to leverage quality data. And at the end of the day, since good data means good AI, that's going to be one way to bring accurate answers out of large language models. Moving on to some of the vision aspects that are driving our roadmap, we think that all the data engineers will do some sort of prompt engineering in the very short term. And that's something that we're enabling in the product. And I'm going to show that in a very concrete manner in a few seconds with a demo. You've all been doing prompt engineering, I guess. The moment you start interacting with the likes of ChatGPT, I'm pretty sure you've all been asking questions and refining those questions to get the expected outcome out of ChatGPT. That's prompt engineering. We think that any data engineer will start doing a little bit of prompt engineering inside of the data pipelines, and that's something that we're enabling through new graphical components. So we're bringing graphical components so that you can start operationalizing that prompt engineering. Because when it comes to data pipelines, the goal is really to do that at scale in an industrial manner and ensure that it's done in a repeatable manner and that you can easily scale to other domains, to other functional areas if you wish to. So let me quickly move on to the demo where I'm going to show you a concrete example where I'm turning raw web data into actionable analytics. So let's put ourselves in the shoes of a barista company. We've been acquiring user reviews from our website. And one of the issues is that the user reviews that we have are not well structured. They lacked the level of structure that would be required so that we can create reports and dashboards. So what we want to do here is to turn that raw web data that is unstructured into something that would be business ready and that we could put in the hands of business users. So how are we going to do that? We're going to use Matillion Data Productivity Cloud. So let me share again my screen. Can you still see my my browser? I'm just checking here because sometimes I'm losing the focus. Kevin, can you just?
Yes, I can still see your browser.
That's perfect. Thanks, Kevin. So let's have a look at the raw data that we're going to use. As I told you, we do have raw user reviews. So people have been writing a blurb on a website, and the problem is that that data, as it is, cannot be put at work. We need to refine it. We need to put more structure so that we can start showing it in reports. So let's jump straight into Matillion Data Productivity Cloud, and I'm going to show you how we do that. So the data has been loaded into a Snowflake table, the very raw data that you saw. I'm going to use here an AI prompt component. So that component, that graphical component, is going to help me as a data engineer to start refining that data. And I'm going to use a very interesting programming language here to define my transformations. I'm going to use English. English is a new programming language. And what we're going to do is do prompt engineering in a graphical fashion. So I've been setting a little bit of the context. So we're going to ask the large language model to put itself in the shoes of a marketing analyst reviewing user comments from a well-known barista company. And that data pipeline is going to do enrichment, meaning that we're going to create new columns out of the very raw data that you saw earlier on. And that's going to be the way we're going to put more structure into the source data and ensure that it's business ready so that we can start displaying it in analytical reports. So here, I've been defining new columns with interesting concepts. Since I have very angry customers that have been leaving reviews on the website, I came with that first concept of an anger score. That's going to be a score between 0 and 10 on the level of anger that the large language model is feeling in the user review. We're going to ask for an anger reason. That's going to be a single word describing the reason why the user is angry. We're going to do a little bit of a sentiment analysis, data classification, answer by either positive, neutral, or negative based on the sentiment of the user. We're going to ask for a summary. The interesting part here is that LLMs can also be very funny. So here we're getting hilarious summaries of the reason why someone left a negative review. I can even check for presence of swear words, what was the product involved in the review, and get a sense maybe of whether the customer is going to churn. Is that a customer that will never ever come to our barista company because their experience was so bad? So I've been running that data pipeline using ChatGPT-4, but I could have also used AWS Bedrock or Azure OpenAI. The interesting part of a low-code approach is that we bring a vendor-agnostic, generic approach to transforming and augmenting the data with AI. So let's have a look at the very outcome of the transformation. Here is another graphical pipeline where you're going to see how the data has been enriched by the large language model. So here I do have the very raw data that you saw at the beginning. Here is the very outcome of the enrichment with the large language model. And if I'm sampling the data here, I'm going to see the different new columns that we've been talking about. I'm going to see the anger score that has been defined using the prompt you saw in the previous component. You're going to see the labeling, the classification of the sentiment, the anger summary, which is always so fun, the detection of swear words, and so on and so forth. From an outcome standpoint, I told you at the beginning that our mission at Matillion with Data Productivity Cloud is to make the data business ready. And that's exactly what we did. The very outcome of the AI prompt component is data that is now structured, that you can now leverage in your analytical processes and that you can put in the hands of your business users. So we started from very raw data, and now you can start displaying the different new concepts that have been set up in the AI prompt component in reports and dashboards. So let's jump back to the presentation. From a use case perspective, what you saw in that data pipeline is actually a collection of use cases that we can enable with AI and with large language models. We've been doing a little bit of information extraction. We've been extracting, for instance, the product that was involved in the bad review from the users. We've been doing a little bit of summarization. So that's how we created that humorous summary of the user review. We've been doing a little bit of data labeling And that's something that is so important when it comes to start processing that data in analytical pipelines. We've been doing a little bit of scoring and sentiment analysis. The interesting part and the power of large language models comes from the fact that prompt engineering is not bounded. You can implement as many use cases as you wish. So that's the reason why here on that slide, that's not a finite list. You could implement pretty much any question that you would be able to ask to a large language model and put that as part of a data pipeline. Talking also about the different use cases that you saw. So here we've been seeing something that was specific to a barista company. We've been looking at customer satisfaction, but back to the slide I saw at the beginning, you could apply that, for instance, for knowledge management. You could put more data at work from unstructured sources, and you could also do that at scale on more functional areas. So I'm gonna stop sharing right now because I think that's maybe where we wanna open a few questions and answers. I have a little bit of an extra, if time allows, which is how we also use internally AI inside of products. So how we use large language models internally in order to bring a better product user experience in the product.
Okay, I think I'm sharing our curious dog here. We look forward to questions. I have a couple here. So one question comes in from Marcos. Do you need to get a ChatGPT license to run this example? That's a good question. So do you need, I pay $20 a month for ChatGPT 4, but Cyril, what are your thoughts on that?
Yes, so indeed, you need a ChatGPT license. So the business of Matillion is to integrate with third-party tools. So OpenAI and ChatGPT is no exception. Here, in that demo, I've been integrating with my OpenAI account and my GPT license. So it's up to you. You can use either the free tier of OpenAI, or you can go OpenAI ChatGPT Enterprise, because we know that some customers might have concerns with the sensitivity of their data, and that's how they would address the security and privacy concerns. They would integrate with OpenAI Enterprise and GPT Enterprise, for instance.
Excellent. Okay. Another question here. How does the role of the data engineer need to change to support what we're talking about here? Cyril, why don't I let you go first? I have a couple thoughts.
Yes, I think it's back to the slide I was showing earlier on. We're seeing that transformation of the role and the job desk of a data engineer. Something I often say in the customer calls I'm having is that our mission is to bring some of the superpowers of the data scientist to the skills of the data engineer. That's exactly what we're doing with that new AI prompt component. We're bringing something that was before only available for a very small audience of data scientists, and we're democratizing to some extent some of the very advanced techniques and tools that used to be only available for data scientists. So at the end of the day, the data engineer is getting more tools, more methodologies, more practices, and is going to be able to address more complex problems. That's also something that will address, that will help extend maybe a little bit the range of data engineers. More people are maybe likely to get their hands on data engineering tools and data pipelines.
Yeah, well put. And I might add that so in the scenario 2, embedding LMs within data pipelines, they need to learn some prompt engineering best practices, and then interact obviously with data analysts and data scientists to get it right. But on scenario 1, supporting retrieval-augmented generation and pipelines that load up vector databases, there are certainly tools that make it a lot easier. But it does seem that the data engineer is kind of a hub, and there are a lot of spokes leading out to other roles that they need to collaborate with, learn from, and teach. And so the data engineer plays a real instrumental role in so much now. They need to interact with, learn from, and teach data scientists. cloud ops engineers for performance and stability, data analysts, machine learning engineers, natural language processing engineers that can help figure out how to chunk text in the right ways. So there are a lot of different ways in which the data engineer needs to evolve, and it's a good time, I think, to be in that role. Okay, so we've got another question here, starting with a comment. Generative AI started with the foundation model to address all use cases. Creating domain-specific use cases or use case-specific models will no doubt help enterprises, but what kind of computing power and resources do enterprises need to customize such models? I'll make one point and then hand it over to you, Cyril. We use within Eckerson Group here, and I didn't use it in this deck, the term small language models to describe what these domain-specific models, because even if you start with ChatGPT, which was trained on oodles of parameters, fine-tuning it or prompting it with RAG requires much smaller data sets. And even some of the bigger public language models are being trained now. It's not a trillion parameters like ChatGPT 4 reportedly required. It's more in the single-digit billions. Now, it's still a high number, but there's definitely a trend of declining parameter counts, both for the large language models and this trend of small language models where you get domain-specific. You need less data than you might think. But Cyril, what are your thoughts on that?
I fully second you on that, Kevin. That's something that we saw also internally. So we have an internal data science team, and they've been playing with the likes of Llama 2, so the 7 billion parameter model. And that's actually something that is much smaller than the likes of GPT-4 in terms of number of parameters. The advantage here is that the likes of Llama 2, Mistral, the new smaller large language models are really handy and made to be fine-tuned. That's the very value that customers are starting to get out of that. And fine-tuning actually does not require that much data and that much processing power. It's all about changing the parameters and, as the name stands, fine-tuning the large language model to better address more specific tasks. So I'm pretty sure some people would be surprised by the volume of data that is required to fine-tune a model. It's not that huge. The only challenge, the only complexity here is the quality and the labeling that needs to be done ahead of time. You need labeled data sets. And yeah, that's the heavy lifting part when you are doing fine-tuning. You need that very qualitative data when you want to do fine-tuning. The moment you've been addressing that challenge from a pure technical perspective, that's not going to be that compute intensive. And if you take ChatGPT, for instance, they've also been easing that process of fine-tuning the model with their set of APIs. So there's work that has been done to make that even simpler and even more accessible to a larger audience.
I agree completely. Well said. So Vivek, we have a few more questions here. Vivek is asking, I think you referred to fine-tuning as well, which obviously you have. In addition to RAG, do you address fine-tuning? So maybe you could talk about Matillion's role in the fine-tuning process.
Sure. So RAG, retrieval-augmented generation, and fine-tuning, different practices when it comes to making the large language model more domain-specific. So technically, what we're providing is a set of graphical components. So on the one hand, for the RAG, what we enable is the ability to load data into a vector store. That's the way you're going to extend the knowledge of a large language model. So new graphical components to load data in a vector store, and dedicated components to look up those vector stores and ensure that the large language model can inform its answer based on the knowledge that is stored in the vector store. So those are dedicated graphical components for the RAG. On the other hand, when it comes to fine-tuning, we're looking at bringing in our short-term roadmap graphical components, specific graphical components to fine-tune the model. As we said earlier on, fine-tuning requires to have labeled data sets. So those fine-tuning components will integrate with the large language models that you saw that we support and help fine-tune the parameters and the hyperparameters, so that at the end of the day, with the labeled data that you have as an input, you're going to be able to fine-tune the model and get more task-specific, domain-specific answers out of the large language model.
Excellent. Okay, Francis is asking, how do you format structured data in preparation for RAG, i.e. transfer rows to JSON or a natural language template? Why don't I let you go first on that, Cyril?
Sure. So again, that's something we've been working on internally because we do have our own RAG internally at Matillion. So it depends on the sources of data that you want to leverage. Not all the sources are always very structured. So some sources might require a little bit of heavy lifting. What we see is that there's a classic set of transformations that you want to apply so that the data is ready to be stored in a vector database, in a vector store. The classic preparation that you would achieve here would encompass the chunking of data. You talked about it in your presentation, Kevin. It's about reducing the scope and ensure that you only store the relevant bits given maybe to a particular semantic concept, to a particular chunk of text that you have as a source. Tokenization is also something that is often required when you want to load data in a vector store. So that's part of our roadmap. We're aiming at bringing graphical components so that you can chunk and tokenize the data. But those transformations are more the technical transformations that you need to apply to store the data in a vector store. I think alongside those technical transformations, there's also a fair element of data preparation and data quality. Like you want to standardize the data, remove the white spaces, the diacritic characters, ensure that all the data is in the same format so that at the end of the day, when the large language model is going to look up the vector store, you get a fair level of accuracy and you ensure that all the data that has been stored is really accurate so that you get the best possible answers out of the LLM. I think it falls back to a very old saying we had in the business intelligence world: garbage in, garbage out. So the vector store is no different than that. I like to say that, yeah, good data means good AI. And yeah, you need to prep the data. So that's going to be, on the one hand, technical transformations, but also a fair amount of data prep and data quality.
Okay, they're still coming in. There's another question here, and maybe I'll take it first because I think it builds on what you were just walking through, Cyril. Hui is asking, is there any good integration example of the traditional DIM/fact-based data warehouse with the LLM? For example, feeding the fact data into large language model and chat with LLM for insights. I think you talked about that some. My view is that language models are just that. They're good at language. They're good at vectorized text. If you're trying to get the facts right, rows and tables from rows and columns from tables, then that's where you can have a SQL database or something like that, traditional structured relational database. And they can exist alongside each other. You got the vector database returning the text to support language models, and then relational databases returning columns and rows to support those facts. And then it comes together into an application that'll have an embedded language model, but it'll also have embedded other stuff for predictive ML or things like that. So GenAI will become more of a feature, and it'll exist alongside and rely on traditional relational databases that are supporting traditional relational queries. Do you have any additional thoughts on that, Cyril?
I fully second you on that. I think one key element is that ability to start doing a little bit of inference into what's inside the warehouse. So get that ability to crawl a little bit the schema and the tables that's part of the warehouse and start to extract that knowledge and send it, use that as a source for the large language model. So that's an LLM knows exactly where the relevant data is stored whenever someone asks a domain-specific question.
Okay, excellent. So Paul is asking, will the data engineer evolve, or will this technology drive the creation of new roles, which span data engineering, data science, and analytics, etc.? So my take is that the data engineer role will evolve. I don't think it's going to create new roles. We've got kind of a proliferation of roles on the data science side already. And so in my view, the data engineer is going to continue to have to be sort of a Leatherman tool or Swiss Army knife, a jack of all trades that knows some machine learning, knows some Gen AI, knows some cloud ops disciplines. So I don't think it'll create a new role, but what are your thoughts, Cyril?
I'm seconding you also on that. I'm seeing an evolution of the role of data engineer, but that's not going to move to another role. I think the data engineer is going to be more empowered. New tools, new methodologies. The new tools are obviously the large language models. The new methodologies, we talked about that. RAG, fine-tuning, those are new concepts that data engineers are going to help put at scale and industrialize as part of the data pipelines. Something that I think is interesting is the skill set, the existing skill set of the data engineer. If you compare it to a data scientist, for instance, the data engineer knows their data ops, for instance. They know the versioning, they know things that are sometimes a little bit close to DevOps. And as you said, as you know, a hub and spoke view of the data engineer, I think GenAI, large language models, are going to be new spokes and as many new skills added to the skill set of the data engineer. But the main problem is to make sense out of data. And the best placed persona to do that so far is the data engineer. And I think is likely to be still the data engineer in the years to come.
So we've got one more question, and I'll read it and then I'll give my interpretation of what's behind the question. Enterprise databases, this is from Ahmed. Enterprise databases are huge. Is there another cost-effective way, rather than converting all your enterprise structured data to embeddings on a regular basis and a vector database RAG layer to access or query the data through an LM? So I think part of the dynamic here is, do you want a suite database that does vectors alongside SQL tables and knowledge graphs and things like that? Or do you want a focused vector database? There are pros and cons to each. I personally think that on balance, a suite approach will handle a lot of those use cases. But Cyril, what are your thoughts?
Maybe that's going to be a bit forward-looking. Vector databases are big right now. I'm pretty sure we're going to see maybe some convergence between the relational databases, the warehouses, and the vector databases. So that's we're going to see more vector capabilities built in the warehouses. I'm making a little bit of a visionary statement here, but yeah, so far I agree on the fact that you cannot throw the entire warehouse in the vector store. It would not make any sense. I think it would even defeat the purpose of the accuracy that you would expect out of a large language model. So you have to pick your battles. You have to pick the most relevant data to address your use case. And again, back to the very topic of that webinar, I think it advocates being more domain specific and picking the battle and just picking the most relevant data for that.
Yeah, and we're at Eckerson Group. We're in the midst of writing. I just finished the first, and my colleague Sumit Pal is writing the second report on vector databases and the dynamics there. So there's a lot going on. So this is great. Really appreciate all the questions and interest from our audience. Thank you, Cyril, and thank you, Matillion, for helping make this happen. I think we can wrap it up for now. Have a great day, everyone.
Thanks a lot. Have a good day. Bye-bye.